question 11 here, the last question in 11a. Okay, and it's asking again, are two vectors parallel? Okay, now we know for it to be parallel, they need to share a scale factor. Okay, I'm just going to introduce a bit new notation before we tackle this question. Okay, don't get me wrong, you can do it without this notation. This is going to be quite helpful going forwards. Okay, so when we have this vector A and we have this vector B, okay, they're different directions. Okay, that's why one's labeled A, one's labeled B. Okay, instead now we use column notation to represent these two vectors. Okay, with the top number being the A direction, the bottom number being the B direction. Okay, we can do this, and we're going to then, what this translates to is that 2A plus KB can then just be written as 2 and K. Okay, and this makes it a lot easier when we're comparing these 2A's and 5A's and KB's and 3B's. Okay, so now the new question we're asking is 2K parallel to 5,3. And we need to figure that out by figuring out, is there this scale factor involved? Okay, and now when we put it into these columns, okay, we realize that the scale factor is times the top and the bottom. Okay, and the top, because there's two numbers on both sides, it has to be, the scale factor is already predetermined. Okay, so lambda here has to be 2/5. Okay, because that's the only thing that makes this top row possible. Okay, so 2K equals 2/5 of 5,3. Okay, what does that then make K? Well, K equals 2/5 times 3, so K must be 6/5. Okay, or 1.2. Right, and that is our final answer.